Hello friends, welcome back to the class of thermodynamics. Till now we have seen what is the thermodynamics, what are different types of thermodynamics, what is thermodynamic equilibrium, what is process, state, what is thermal equilibrium, what is zeroth law of thermodynamics, what is heat and work, how to find work in different types of processes. So till now we have find or we have discussed about these things. Now, in today's session, we will talk about the first law of thermodynamics. What is the first law of thermodynamics? Okay, so coming to the first law of thermodynamics, it is came from the experiment. The first law came from the conclusion of one experiment. The experiment was held by Joule, a scientist. Okay, so based on him, the first law of thermodynamics came in the role. Now, this is a setup. What the Joule or his team made a setup. This is the setup. What are the things here? Look carefully. A beaker is there which is filled with water. This blue color is water, and these circular things are nothing but molecules or atoms. Now, in this beaker, we have closed it, we have made it closed system, and then we have insulated it. We have insulated it. So what we are doing? We are making a isolated system. Here we are making a isolated system so that there should not be any transfer of mass as well as no transfer of energy or heat, you can say. Okay. Now water is there, an insulated beaker is there. We have dipped thermometer to measure the temperature of the water. Now this is a exterior mechanism, and this bottom red color, this is a pedal wheel. Okay, it will rotate. Now this stereo mechanism top there is pulley from where a rope or you can say a thread is there, wounded there. Okay, now this thread is coming here. Here one more pulley is there from which this thread or rope is suspended downward. At the another end of the thread, there is some weight. There is some known weight. It is suspended from the rope. Okay. Till now the things are clear. Again I will describe you about the setup. This is a beaker which we have insulated to make it adiabatic or to make it as an isolated system. Inside this beaker we have filled some water up to some level. We kept one thermometer to measure the temperature of the liquid. Then there is a stereo mechanism. Okay. At the bottom end there is a pedal or we can say steerer wheel which will rotate. On the top end there is pulley attached to this mechanism. From the pulley a thread or a rope is going out. Okay. Now one more pulley is there at some distance from where this thread is suspending, and at the other end of the thread some amount of known weight is acting downward or suspended downward. Okay, so this is the mechanism. Now a thermometer, we measure the temperature, let it be T1, and same temperature we are maintaining at the surrounding also, T1. Okay, so this is the initial condition. This describe about the Joule experiment setup. Now what we will going to do? See, now we have lowered the surface weight by jet distance. This was suspended vertically downward weight. So we have pulled this weight downward and moved it with a distance z. What will happen? When this weight will come down, this rope will also come down, this rope will move and it will rotate this steerer mechanism, because of which this pedal wheel will rotate. Okay, when this wheel will rotate, what will happen? It will create agitation it will displace the molecules. So it will create the kinetic energy. Now, if kinetic energy is there, what happens? There is change in temperature. So what will happen? The temperature will change. Temperature will rise. This will become heat. The temperature will rise. Let the temperature rises up to T2. Let because of the moving down of this weight, this stereo mechanism is rotating. Because of the rotation of this stereo mechanism, this pedal at the bottom, this is rotating pedal wheel. Now when the pedal wheel is rotating, these water molecules will move. It will create kinetic energy, which results in raising the temperature of the liquid or increasing the temperature of liquid, which is measured through thermometer. We have measured this temperature of fluid through thermometer. Let the temperature rises to T2. Till now the things are clear. Now what we are going to do? Now we are removing this insulation. We are removing this insulation. So what will happen? Again, this temperature T2 will try to come in equilibrium with surrounding temperature. When you will remove this insulation, what will happen? The temperature T2 will be try to come in thermal equilibrium with surrounding temperature. So again it will achieve temperature T1. Okay. Now, because temperature is changing from T2 to T1, due to change in temperature or difference in temperature, there will be heat transfer. There will be heat transfer. Okay. So two things are happening. How much will be the heat transfer? mCp delta T. mCp delta T. Change in temperature T2 minus T1. Clear? Now we are drawing a graph. We are showing this process through a graph. This is completing one complete cycle. How? Initial temperature was T1, then it was raised up to T2, and again finally you achieve temperature T1. So one complete cycle is there. It's starting from T1 going to T2 and again coming back to T1. Now, if you will see this graph carefully, from process 1 to 2, there is work done W12. Now coming back to 1 from 2 to 1, there is heat transfer Q21. See, when we are going in process 1 to 2 or path 1 to 2, work is done W12. But when you are again returning back from 2 to 1, process 2 to 1, there is heat transfer. How? So when initial case when the weight was lower, so what is happening? Due to the height, there is potential energy. So there is work done due to the potential energy. Okay. In the next case, what is happening? That there is temperature change and the loss of heat. When you remove the insulation, there is loss of heat. Okay. So in to process 2 to 1, there is heat transfer. Process 1 to 2, there is work transfer, that is equal to potential energy. Process 2 to 1, there is heat transfer, that is equal to mCp delta T. Okay. This is, so you can see that in complete cycle there are two things. One is heat transfer, one is work transfer. Both are path function, both are form of energy. So from this observation, the Joule he found the first law of thermodynamics. First law of thermodynamics for a closed system undergoing a cycle. Again same graph here you can see process 1 to 2 there is work transfer, process 2 to 1 there is heat transfer. So there is no other thing, only one work transfer, another heat transfer. Okay. Same thing is here. Cyclic integral of W means work done for a cycle. This is equals to J times cyclic integral of Q or summation of Q, sum of all the heat transfer in a cycle. Summation of all the work transfer in the cycle is equals to J times summation of all the heat transfer in cycle. Okay. This J is nothing but Joule's constant. J is nothing but Joule's constant. Someone pronounce it as Joule also. Okay, and this is equals to 1. The value of this is equals to 1 Newton per meter Joule. Okay, the value of J will be 1. So another form is, here first form it is summation, in next it is cyclic integral. So you can represent in both type. For a cycle, this is for cycle, na? This is for a cyclic process. Total heat transfer equals to total work transfer in a cycle. Now for change of state, not for a cycle, this is for change of state. This is not for a cycle. Okay, if it is not for cycle, then what will happen? In previous case there was only work transfer and heat transfer, but now here there is change of state, there is not a complete cycle. Then there will be heat transfer, work transfer, as well as delta E. Delta E is nothing but internal energy, or energy possessed by the body. Energy possessed by the body. Okay, so Q equals to delta E plus W. Total heat transfer is equal to total work transfer plus change in energy possessed by the body. Now taking this example, lot of heat transfer is there and lot of work transfer. Some are positive, some are negative. Now if you will remember the sign convention, what are the sign convention? The work going out from the system. Work going out from the system means system is doing work. It will be positive. Work coming inside the system. Work coming inside the system means work is done on the system. Okay, so it will be taken as negative. Now talking about heat transfer, I have given the example of money. If you are getting money means you are in profit. If you have to give money means you are in loss. Same thing. If heat is added to the system, heat is coming towards the system, or heat is added to the system, it is positive. And if heat is going out from the system means if system is losing the heat. Okay. So if the system is losing, if system is losing heat, then it is taken as negative. So from this diagram you can write the expression Q2 plus Q3, because these are added to the system, minus Q1. Why? Because Q1, the amount of heat system is losing, it is going out from the system. So Q2 plus Q3 minus Q1, this is total heat transfer. This is equals to energy possessed by the body, delta E plus work transfer, W2 plus W3 means system is doing work. W2 plus W3 positive. System is done on the system means minus W1 and minus W4. So this is giving you the first law of thermodynamics for a change of state. Previously it was for cycle. So there was no energy possessed. There was no internal energy. But here this is for change of state. This is not for a cycle. If it is not for a cycle, then there will be a term extra, which is nothing but change in energy. Energy possessed by the body. I hope this is clear. So we know the first law of thermodynamics for both the cases. One for cyclic process, one for simple change of state, or for a one process only, not for a complete cycle. Now numerical based on this. Here given, in a cyclic process, heat transfer is given to you. Plus 14.7 kilojoule, minus 25.2, minus 3.56, plus 31.5. These are the heat transfer. And you have to find the net work transfer. Here it is given, it is a cyclic process, heat transfers are given to you. Now you have to find the net work transfer, means total work transfer. Now for a cyclic process, what is the first law of thermodynamics? So this is the first law or thermodynamics for the cyclic process. Total heat transfer equals to total work transfer. Total heat transfer equals to total work transfer. Now what is total heat transfer? You add all these four quantities. You add all these four quantities, you will get total heat transfer. Now from the first law of thermodynamics for a cyclic process, total heat transfer equals to total work transfer. So this total heat transfer value 7.44 is equals to total work transfer, which you have to calculate net work. Clear? So this is the one kind of numerical based on the first law of thermodynamics. These can come in the exams. Okay. Next, numerical. During a cycle, burning fluid in an engine engages in two work interaction. So a cyclic work is there. Now there are two work interactions. 15 kilojoule to the fluid, 44 kilojoule from the fluid. Okay, and there are three heat interactions. There are three heat interactions. See, two work transfers are there, 15 kilojoule and 44 kilojoule. One is to the fluid, another is from the fluid. Next, there are three heat interactions. Out of these three heat interactions, two are given to you. Two are given to you. 75 kilojoule to the fluid, 40 kilojoule from the fluid. So, two work transfer given to you, two heat transfer is given to you. You have to find third heat transfer. Okay, you have to find the third heat transfer. Now you will proceed. See, this is the system. Now it is given about work interaction first 50 kilojoule to the fluid. Here fluid is our system. Fluid is our system. 50 kilojoule work is done on the system means it is negative. Minus 15 kilojoule. Next 44 kilojoule from the fluid means fluid is our system. System is doing 44 kilojoule of work. So W2 is positive 44 kilojoule. Okay. Now coming to heat. 75 kilojoule to the fluid means you are adding 75 kilojoule of heat to the system. If system heat is added means positive. So Q1 75 kilojoule positive. Next 40 kilojoule from the fluid means you are taking 40 kilojoule of heat from the system. It is negative. Okay. Now third heat transfer you have to calculate. So how you will calculate? Write the first law of thermodynamics for cyclic process. Total heat transfer equals to total work transfer. So total heat transfer is how much? 75 minus 40 plus Q3. Q3 is unknown. Now total work transfer is how much? Minus 15 plus 44. Substitute the values, solve it, you will get Q3 equals to minus 6 kilojoule. So the unknown heat transfer you have got minus 6 kilojoule. Minus is showing the direction and 6 is the magnitude. Minus means heat is coming out from the system, means system is losing the heat. So 6 kilojoule from the system. This is the final outcome. Friends, it is clear. We have seen the two kinds of questions. In one, you have find total heat net work, total work. In second case, you have find the missing value. You have find the missing value. Okay. These are the two types of problems. Okay. So this is the third problem. Note down this and you solve this and write the answer in the comment box. Note down this problem, solve this problem and write the answer in the comment box. Okay. So thank you for today's session. I hope it was fruitful to you. We will meet you in the next section of thermodynamics. Till then, goodbye and take care.